All right, it is 8 o'clock, so good morning, everyone, and welcome to day 29 for the Rankin Technical College online AWD 1100 C# programming class for the summer 2023 semester. Today is Monday, July 10th. Now, pretty ambitious what we plan on going over today, but some of it won't take very long. I do want to quickly kind of bring to a close chapter 16 on class libraries, but we won't spend very much time on that. Afterwards, I have gone back and decided we are going to go over chapter 13. Again, I don't think that'll take real long. I sent you all an email this morning, the email that you see right here, and one of the things in that email, or one of the many things, were the user interfaces for two inheritance programs that we're going to go over in quite a bit of depth and breadth of coverage this morning. Then afterwards, we'll talk about the end of the semester requirements for your electronic portfolio. I'll show you how to install and create a simple electronic portfolio using MobiRise. Then I'll show you how to save that electronic portfolio to GitHub Pages. All right. In addition, I've got in there the attached end of semester project requirements. And when you read through that, it won't make a lot of sense because the majority, just about everything in there, is from chapters 18 through 22. So if they don't make, if the instructions there make little to no sense, please don't worry about it. All right. Finally, we'll go over the hot number 5, the test on chapter 12 you took last week. Some people struggled with that, and I want to make sure everybody's got an idea of what was expected in there. All right. Now, again, I'm going to go over 16 and 13 first. And after we get done with 13, spend a little bit of time going over. And I found some of this stuff, some of the reading for the Microsoft Learned on Microsoft.com is just kind of dry. So I found these things under tutorialsteacher.com and one under tutorialspoint.com, which I thought read a little bit better. So we're going to go over those. Tomorrow, as it says, you can read this, but tomorrow we're going to write code. All right. And tomorrow I also plan on emailing you the pretest that we will do as a class on Wednesday. And then on Thursday of this week, you will take the chapters 13 through 16 hands-on test, which means that 1 week from today, all right, on Monday the 17th, all right, we will be now finished with the first 3 sections of the book. So a week from today, we're going to go over and 18. Will be all right. The week after that will be chapters 19 through 22, and that'll end the book for us. Okay, so with that said, let's just quickly go in, and I want to talk to you about some problems I had with the material in chapter 16. No, it doesn't want to let me go there, and I don't know why, but it doesn't. So let's try it again. All right, so chapter 16 was on how to document, organize, document, and test your classes. And they talked about, this is the main thing, this creating a class library. Now, they're not hard to do. However, I had a problem with the class libraries. All right, let me show you or see if I can quickly recreate the problem that I had. Not sure if I can or not, but I'm going to try anyway. So I'm going to come in here and make one of my infamous junk folders. All right, so start up Visual Studio. I just very quickly want to show you the problem that I had, okay? So I'm going to create a new project. It'll be a Windows Forms app. And I'm going to just call it Junk Project. And the solution will be Junk Solution. and I'm going to save it into the junk folder that I just created. All right, now I'll click create. Now there's nothing new here, okay? I'm not going to be really doing much of anything in here. I just want to show you the problem that I had. All right. So there it is. Now I'm going to right mouse click on my solution and I'm going to choose add new project. And now I'm going to choose class library. All right. And I'm just going to call it junk library. Okay. And what it had been showing me was 6.0, and this is where the problem is. So I went back and tried 2.0 and 2.1. Let's try 2.0. Now, if for some reason what I'm going to try, if it works today, well, then I'm going to have to go back and massage and some of the lectures and stuff we've talked about. So I'm going to come in here and I'm going to just try this. I'm going to say private underscore name, private string underscore first name, private string underscore last name. We're going to keep it real simple like that. Public class one, and we'll just keep it the way we've been doing it, kind of like this. All right. And then I'm going to come in here and I'm going to do a getter and a setter. So public, in fact, I guess we won't even need these. Let's comment these two out. So I'm going to say public string first name get set, public string last name get set. Okay, so those are done. I can initialize those, but I really don't have to. Let's put in another class here or another constructor. All right, so that's everything. I can go back and I can add more stuff to this. I'm trying to do something very simplistic right here on purpose. All right. Okay, so now I've got this. I've got this class that I've created. Nothing new here. We gave it an empty constructor. We also gave it another constructor where we are basically assigning what we pass in here. So nothing new here, right? All right. So now I'm going to go back to my form. All right. And let's just add a button. Again, I'm not real concerned right here with pretty or with much of anything else. All right. And we'll just call this BTN instantiate. All right. And I'm going to put instantiate on here. All right. Nothing, again, nothing new there. I realize this. All right. So there we have that. Now, if I come in here, just lock that. But if I come in here now and I say this, I'm going to say class one person equals new class one. All right. And we'll pass both of them in. We'll pass in Jeff Scott. And you'll notice right now, it says the type or namespace could not be found. Okay. So if I come in here and I click here and I say add junk library, all right. Well, the weird thing is now it appears to be working. That is great if it does. So let's come in here and do this. So I'm going to come in here and say, we're going to come back to our class and we are going to do a public string toString, and I'm just going to leave it like this. Let's declare a body. Yeah, I know we're giving it a body right now. All right. So we're going to say return first name plus first name plus, all right, we'll just put a blank space in there, plus, and then last name plus last name, like that. All right. And I'm going to see if this works. Add the override keyword public. All right. So let's see. Oh, I better tell it to show on the screen. It's returning it, but let's go into our design mode and let's add a label here. All right, we will play with some colors here, and let's do this. All right, and let's do this. All right, and after we've got this and we've instantiated, I'm going to say L, give it a people, and we won't put any text in there at all. And we will set it up so it's nice and big so we can read it and make sure that it works. All right. So when I click this now, it should have first name Jeff, last name Scott. And it isn't doing anything. Did I tell it to be put there? I don't think I did yet. There we go. LBL people dot text equal person. Okay. I've got a toString on there. What doesn't it like? Can't convert. Show potential fixes. It's a Monday. What can I tell you? Okay. I'm just going to do it like this. This isn't the way I want to write this, but I don't want to waste my time or your time. All right, so let's see if we get some output. All right, we are. It's working. All right, this did not work before, but what we've done here is something pretty incredible. All right, what do I mean? Okay, what do I mean here when I say what we've done is something pretty incredible? That is, what we've been able to do is we came in and we created another project that held a very simple class that we created. Then, because of the fact that we used that class that we created in our form, we were able to go in and actually implement a working class library. This is great. It really is. What this means is the project that I'm going to do with you, the two projects that I'm going to do with you later today, I'm hoping we can do the same thing and add a class library in those also. All right. Okay. So that's what I wanted to show you from chapter 16. The other thing that we really didn't go over at all in chapter 16 was the concept of unit testing. I'm not going to run through that. All right. But basically, when you unit test, what you're doing is you're taking a project and testing the individual pieces of the project. All right. I'm just going to leave it like that for right now. And with that said, I'm going to jump back over to chapter 13. So as we look at our stuff that we're doing today, and I showed you this earlier, all right, we now have completed what we're going to complete in chapter 16. So we're going to go over chapter 13. After we do that, we will work on these two inheritance problems that I sent to you in an email this morning. All right. From there, as you know, we'll just go on and do the other stuff as well. Okay. All right. So let me jump into chapter 13 here. And chapter 13 is how to work with indexers, delegates, events, and operators. Now, I'm going to try to take this whole chapter, which is not a real short chapter, all right, not a real long one either, about 29 pages. But what I want to do is break this down for now into a sentence. And what we want to be able to do in here is we want to be able to take and work with classes, all right, and basically be able to do the same kind of operations that we do with variables. We want to be able to do those with classes. I'm just going to leave it like that for now. So we're going to talk in here about indexers, throwing argument exceptions, defining delegates, raising events, and overloading operators. I will tell you, I am going over this chapter for completeness. All right. You do not have to do, I want to repeat this, you do not have to do anything for chapter 13. No homework, no labs, no written test. All right. I'm going over this again for completeness. All right. So as we look in here, an introduction to the project list class. So if we look here, thought there was a picture and maybe I'm wrong. Okay, maybe not. All right. It says, as you may recall, the product maintenance app that we discussed back in chapter 12 used a variable of type list product to store product objects. All right. So now what they're going to do in here is the product maintenance app in this chapter will use a new class named product list. The class is going to represent a collection of product objects. So we're going to look at the code in just a minute. The key note here is it says the class coding techniques discussed in chapter 12. Now, they said, as a result, you shouldn't have any trouble. No, that isn't really a fair thing to say. This by far, in my opinion at least, has been the hardest thing we've covered so far in this book. All right. I should mention I did grade everyone's test. All right. And I've got your grades out there on the system. All right. I'll try to remember that sometime this afternoon or this evening to send you all an email that has your test page on it so you can see if you lost points, where you lost points. All right. So it says the product list class defines a private list product variable named products to store the product list. So if we move over, there that is. All right. Next, it provides a constructor with no parameters to instantiate a new list, followed by a count property that indicates how many products are in the product list. So if we look right here, All right. And I think you all know this already, but I want to show this to you. Again, I am trying to be at least somewhat complete here. So this line that you see right here, I'm going to reproduce it. It says public product list. And that's cool. That's pretty much the newer syntax that you're going to see with this. But that's the same thing as saying it's basically the same thing. So what we're doing is we're creating a new product list constructor that's taking in no parameters. Again, this is the newer way of doing it. This is the older way of doing it. Now you'll notice when we look after that, we've got some methods. The first method that we have there is a count method. Well, that's something that any list can do is it can give a count of how many components it currently has. Now, typically when you set up something either like this or like this, if it is a list like this, it has a size associated with it. All right. My guess is with this, and I could be wrong on here, I think it's like 16 that it automatically sets it up to. And again, they may say it in the book, and I may be wrong. All right. But whatever happens, one of the things that differentiates using a list from using an array, and one of the reasons developers like to use lists is if you butt up, let's say that it's 16. So let's say we do this and it sets up an empty product list with a count of 16. If you put in 16 items, boom, it automatically doubles the size of the list from 16 to 32. If you get up to 32, boom, it doubles it again and it makes it 64, etc. So you can see where we're going here. You don't have that nicety, so to speak, with an array. It just doesn't work that way. All right. All right. Then we've got an add here. Pretty simple. Adds a product. We are adding in the individual pieces. So we are processing or bringing in a code, a description, and a price. And once then we go and instantiate a new product based on those three attributes, and then we add it. All right. Then if you notice, there's a get product by index. The idea with a get product by index is we're going to be able to use that for searching. All right. It's going to show us if we're looking for a particular product, the index that is associated with that product. The remove is just that. Now, the way it looks in here, they're just doing a remove. They're not asking you, are you sure you want to remove this, etc. All right. Then we've got a fill and we've got a save. And you'll notice with both the fill and with the save. So with both of these, you'll notice it works with that product DB class that we really haven't discussed in here at all. And we haven't discussed that because we have not yet gone over the topic of databases. All right, we will, just not for a couple weeks yet. All right, now, if I missed anything in here, I didn't mean to. All right, so read it yourselves, okay? I'm trying to give you this in the most straightforward way that I possibly can. All right, so it says the next figure shows the specifications for an enhanced version of the product list class. It says to start, it provides two indexers. This is new, that let you access a product based on its index or product code, rather than using the get product by index method. Besides these indexers, the enhanced product list includes a plus operator that adds a product to the list and a minus operator that removes a product from a list. What they are talking about here is one of the things that will be discussed toward the end of the chapter. All right. And it'll be on the last thing there will be on operator overloading. All right. If you've got two numbers, I'm not going to put up any code or anything right now, but if I've got two numbers, let's say that I've got an int that's set to 32. So I've got int number one equal 32 and int number two equals 50. And then I say sum equals int one plus int two. So if it was 34 plus 50, it's 84. There's no big surprise in there. I'm adding a couple of integers. However, that kind of thing does not work when you are using objects. All right. It doesn't make any sense really to add one object to another object or to subtract an object from an object unless you go through operator overloading. And we're going to talk about that toward the end of the chapter. All right. What indexers do in a nutshell is they allow you to take whatever your class is, and let's assume that you create a class and you create an array or a list of objects of that class. It allows you to iterate through that list or iterate through that array of objects. All right. Finally, as it says, this class includes a delegate named change handler and an event named changed. Now, we've kind of been working with these all semester, but behind the scenes. All right. So, in other words, if we go back and you go back in here and you look as an example here, if we go back to what we were looking at a little bit ago, I think I left that up here. Good. And I go back here and I look at in here under my project, and I don't want references, but I want to look at this designer here, this thing. If you remember this kind of stuff, we talked about this a little bit earlier, this stuff. All right. And how basically when you sit and bring stuff out onto, when you bring stuff out onto your interface, that a lot of this stuff gets drawn or created for you in the background. All right. And we're still kind of talking about that right here with what we're getting into. All right. Now, what does this have to do with anything? Well, first of all, think about what a delegate means. All right. And I did give you a couple of articles on delegates. And what the article, what they mention in there is they use an example that's not computers. And they say, let's say that you've got Bill, and Bill has agreed that Bill is going to create, he's going to paint a piece, an artist. He's going to paint a picture for you of Rankin Technical College. All right. Well, Bill got so busy that he's not able to paint the picture for you. However, Bill has an artist friend named Mary, and Mary has agreed because she owes Bill a favor to paint the picture for Bill. All right. So basically, Mary is kind of the delegate. She's someone who's been delegated the authority to do something by Bill. And as long as she creates the picture, all right, gives it to Bill, who can give it to whomever, basically contracted him to do it, they're not the wiser. All right. Well, in this kind of the same way, notice what it says here. This class includes a delegate named change handler and an event named changed. All right. The delegate is designed to wire event handlers to the changed event of the product list class. The list class raises this event whenever the contents of the product list change. In other words, anytime you're making a change to this list, meaning you're either A, adding a new product to the list, B, updating an existing product from the list, or C, removing an existing product from the list. All right, as it says, the product maintenance app will use this event to determine what it should do. So anytime we make one of these three changes, all right, we either make an addition, a modification, or a deletion, it knows that it's going to have to save what we've done, update our product list, and then refresh the list box that displays these. All right. And this is starting to get us on the road to where we're going to be getting to talking about using databases. Now, that was just kind of a prelude, but this is what's in here. So it's got a constructor, an empty constructor to create a new product list. It's got two indexers. One, as it says, provides access to the product at the specified position. All right. And another one that provides access to the product with the specified code. We'll look at it in a minute. The count property we've already talked about. You'll notice that we've already talked about the add, and we've talked about the remove. The fill and the save hopefully just makes sense. And there's our overloaded plus and minus. So we can use the plus operator to add a product object to a list and the minus operator to remove a product object from a list. We've got a delegate, which, as it says, can be used to register the method that's used to handle the changed event, then the changed event itself, which we just mentioned is going to allow us to either add a new product, update an existing product, or remove an existing product. All right. So let's get into this a little bit. Again, you will not be tested on this. You will not be given an assignment on this. I am trying to go through this to be as complete as possible. Last week, I showed you an email that I sent to Mr. Gudmested saying, hey, I'm not even going to go over 13. He never got back to me. All right. And that's okay. In fact, he got back to me this morning, and I think that he said that he was gone last week. I don't know if he took a mini vacation or exactly what he did. I don't know. All right. But he said, where was it? He said, hi, Jeff. I'm just returning to the office after a few days off and realized I missed this email. Sorry for the delay in my response. I'll follow up today. And I wrote back to him, no problem. Thank you. FYI, I decided to go through all chapters, including chapter 13 after all. And I went back and looked at some of the stuff that he had done, and he went over it when he taught the class last too. All right, so let's talk about an indexer. If you don't like the description here, all right, or if you don't like the examples here, if you look here, this is what I took out of Tutorials Teacher. They've got an entire C# tutorial here. All right. Most of the stuff that's in here, most of it we've already talked about, not everything. You know, and there's loops, etc. Yeah. But this is where I leaned on for some of this stuff. All right. So if we look at that and then go into here, there are C# indexers. Now, I kind of liked close. Doesn't want to close. Kind of like the description that was given here. An indexer is a special type of property that allows a class or a structure to be accessed like an array. It allows us to define custom indexers, generic indexers, and overload indexers. Well, you should by now already be at least somewhat familiar for example, for a custom indexer, all right, that'll handle a specific data type. Okay. If we've got a generic indexer, it's more designed to handle pretty much any data type. And we can also overload indexers. But they give you some examples in here that may or may not make sense. Right? And it's totally okay if it doesn't. But let's jump back into the book. Like I said, I put that out there so that if you don't understand the explanation that I'm giving now, you've at least got something else to look at. All right. So again, an indexer is a special type of property used with classes that represent collections of objects. It allows other code to access a specific item in the collection by specifying an index value. So let's look at the examples that they give here. It says the first example in this figure shows an indexer for the product list class. So the first example is the one right here. First thing to notice is it uses the keyword this in here. All right. So the class declares a private list product field named products, which is used to store products within the product list object. Then the indexer with type product is declared. Notice that this indexer is not given a name. Typically, in many programming languages, when you've got something like that that's not given a name, it's known as being anonymous. So rather than having it have a name here, it uses the this keyword, which refers to the current object. Since it's doing that, since it's working with objects, you can't have something static. Remember, if something is static, it applies to, there's one of them for the entire class, no matter how many objects there are. Can't do that here. The this keyword is followed by a parameter identifying the index used by the indexer. This parameter is coded within brackets. So that is what you see in here. All right, so public product, because it's working with this and it's using the current one. And again, rather than parentheses, it uses brackets. But other than that, it kind of, well, not even kind of, it pretty much looks like a property. But instead of returning products or product equal value, we're working with elements. So it is working with an individual product object. All right. Like I said, I'm hoping that makes just at least a little bit of sense to you. Like any other property, an indexer can provide both a getter and a setter. All right, and that's what we just looked at. Or if desired, as an example, here's one with just a getter. So what are we doing? It's a read-only one that uses a string as an index. What does that even mean? Well, public, it's going to return a product, and it's going to be working on basically our list of products. We get a code passed in, and what we do is we cycle through our list of products, and if that code that was passed in is equal to one of the codes that's in a product right now, we return the entire product. If we get all the way through it and don't find a match, we return null. All right. Like I said, I'm hoping this makes at least a little bit of sense. So a class can have any number of indexers as long as the parameter lists are different. So you can overload them. All right. Again, nothing new there. The second example shows another indexer. All right, it doesn't include a setter, so it's read-only. It's the one we just looked at. Second, it uses a string index that provides for getting a product by the code. All right, just exactly what I just mentioned to you. If you have null reference types enabled in Visual Studio, you may get warnings on this. To remove that, you can use the exclamation point, or you can throw an exception. Finally, the third example in here shows how you can use these indexers. The first two statements create a new product list object and add a product to it using the add method. Then the next two retrieve the product, all right, from the list and by product code. Finally, it says here, the last statement uses the setter to assign a new product to the list specified by variable I. So when we look in here, this is the stuff they're talking about. But you'll notice that we are, with these indexers, we are basically referring to the objects that are in a list as though they were array elements. It's not exactly the same thing, but you could kind of look at it that way. So, as the author mentions right here, an indexer again is a special type of property that lets the user of a class access individual items. All right. Before you add an indexer, you should create an array or a collection of private instance variables to hold the objects you're going to be working with. The declaration for an indexer uses the this keyword and a parameter that's within brackets. All right. It should return the object specified by the index value that's passed to it, if it exists. Although the index is typically an int, as you just saw in the example, when we passed in a string for the code, it doesn't have to be. You can code two or more indexers with different parameter lists, which is known again as indexer overloading. Okay. Now, like I said, this is getting about probably as heavy as we've gotten with anything all semester. All right. Does it make sense? Conceptually, it makes sense. And that's what I'm looking for. All right. In chapter 12, it says you saw that you can code read-only properties that simply return the value of an expression using an expression body. This applies to indexers as well. So if we look in here, and this is some of the newer stuff. You can do things like this. Now, I believe that's the same one that we'd actually looked at earlier, unless I'm mistaken here. That was right here. The difference is right here, I should say, we don't have a set here. All right. So there it is. But we can also use this with an expression body. Again, using this lambda type of expression with the equal sign followed by the greater than, you're going to be using this more and more as we go on. And what I mean is you will be using this both in the AWD1111 class, which is database-driven web development, and in the AWD1115 database-driven web development 2 classes. So you will use this in the future, both when you're working with server-side stuff using MERN MERN being MongoDB Express, React, and Node.js, and you'll use it in your last class where you will end up working with ASP.NET and C#. But this is used a lot anytime you're referencing things using LINQ. And LINQ is something that's going to be discussed again in chapter 18. So it's coming up. All right. So if an indexer is read-only, you can code it as an expression-bodied indexer. All right. If the getter simply returns an expression, it can be coded as an expression-bodied accessor. This is something that was introduced fairly recently. All right. So if you want a setter in here, you can do it like this as well. So there's an indexer with an expression-bodied getter and setter. All right. So there's different ways this can be done. Bottom line. All right. Now, how to throw an argument exception. The good news is you know how to throw exceptions. The bad news is it's kind of done a little bit differently in here. All right. So it says when you code properties and methods, it's often a good idea to check the arguments that are passed to them to make sure that they are valid. All right. Then if an argument isn't valid, you can throw an exception to notify the user of the class that an error has occurred. Well, that should make sense. All right. For example, when you code indexers, you might want to make sure that an argument falls within a given range. Okay. So in other words, if you know that you've got 10 things in a list, you don't want to go, there'll probably be 0 through 9. You don't want to go over that or under that. All right. So it says the next figure shows how argument exceptions should be handled. All right, the getter, as it says, checks for the int that comes into it to make sure it's valid. If it's less than 0 or greater than or equal to the number of products in the list, it throws an exception. Otherwise, it handles it. So when you look in here, there it is. Now we've looked a little bit. We have actually looked in a little bit in here in the argument out of range exception. We have used that one in the past when we've been using, for example, the validator class. All right. And we had a minimum and a maximum in there, if you remember. All right. To make sure that, that is within range. So it's not that different in here as far as what we're doing. Now, in here, notice if it's out of range, we're throwing this. Now, if we don't handle it some way, because this is just in a getter. So if we don't handle it some way, the program will. And typically with any kind of exception, if the programmer doesn't handle it, the program will. And quite often the way that the program will handle it is it will shut down the program. All right. The second indexer, it says, works in a similar manner to the first one, but it accepts a string that specifies a product's code. So in other words, we're using a code here. All right. It says it uses the throw if null to throw a null argument exception if no code is provided. Next, it checks the code. If the code contains more than 8 characters, you get an argument exception. Otherwise, it does a for each loop, which is going to go through and basically either return the code if it finds a match or null if it does not. All right. It says here, as you learned in chapter 7, the throw statement and throw expression specify an exception object to be thrown. .NET defines the exception classes, all right, listed, and there's a lot of them. All three of these exceptions, as is mentioned later on down here, have a constructor that accepts a message parameter. We've used the message before. All right, so there's nothing new in here. All right, now notice when they are throwing this argument exception, they are providing their own message for it, which is legal to do. All right, it's kind of nice because otherwise, if you just throw a new argument exception, you get a very terse, very generic type of error message. All right. So as mentioned here on the bottom of page 431, if a class detects an invalid argument, it should show one of the 3 argument exceptions that are shown up above. With C# 10.0 and later, you can also use the throw if null method of the argument null exception to throw that kind of an exception. All right, that's it for indexers. So the next thing that's in here is delegates. And again, with these indexers, the example I gave you, or the thing that I showed you, they've got a bunch of examples in here, which are by and large fairly simplistic. All right. So the next thing that's in here is delegates. And you have both here, these delegates, and I also provided for you again, if you're interested, and if you're not, you're not. But let me open that. Understanding C# delegates the easy way, and here's the basics. This is that example I gave you about getting a painter. All right, and then they've got one that goes into a little bit more depth and breadth of coverage. All right, and that's part 2, talking about anonymous methods. So feel free to read that. All right, I just want you to have at least an understanding. And sometimes people ask, okay, that's fine. If you're not going to test us on this, and you're not going to make us do any labs or any homeworks or even a written test, why are we even going over this? Well, it's not outside of the realm of possibility that you could apply for a job, possibly a job, as a C# programmer. And then they might say to you, hey, Bob, hey, Mary, what do you know about C# delegates? and at least you've been exposed to them. And you could say, we didn't really work with them much in the class I took because it was a beginning class. But, all right, I know that basically if you want to pass a function as a parameter, you can use a delegate. So that basically is what it is. If you want to pass a function into a function, you can use a delegate. All right. And there's 3 steps involved, as it says here. You declare the delegate, you set a target, and you invoke it. So let's jump back into our book and see what the heck any of that stuff even means. All right. So as it says there, in addition to fields, properties, indexers, methods, and constructors, a class can also define delegates and events. A delegate, as it says, is created from a class and can refer to methods with a specific return type and parameter list. You can think of a delegate as a pointer to a method with the given signature. In other words, a method can be called indirectly through a delegate. And again, as I mentioned to you previously, it's kind of like the idea of a human being who designates somebody as their delegate. All right. In many cases, it says you'll use delegates to write event handlers to events. You can also use delegates without events. Okay. So they mention there. To define a delegate, you start by coding the public and delegate keywords, followed by a return type, the name of the delegate, and the parameter list. So if we look here, public delegate void change handler. So you can tell already, this is a delegate, it returns nothing, this is its name, and this is what gets passed into it. All right. Says you can use this delegate with any method that has the same return type and parameter, which forms the signature of the delegate. All right. In this figure, it says the print to debug method has the same signature as the change handler. So this method is coded in the main form, then it's called from the load event handler after the product list object is created and added to it. And again, as I said, I would think at least this is probably about as heavy as it gets as far as what we've done in here thus far. So to use this, it says you start by creating an instance of the delegate. It works the same as instantiating any type of object. However, in this case, because it's declared in the product list class, the name of the delegate is qualified with that class, meaning you got to say product list dot. All right. You can also specify the method that's used by the delegate when you instantiate it. After you instantiate or create the delegate, you can call it and pass all arguments by the method it refers to. Now, they even mention in here, this is not a very realistic example, but it's meant to just provide a little basis for you as far as what's going on. And I don't want to go into it in any more depth and breadth of coverage for the same 2 reasons I gave you before. Number 1, all right, we're not going to have any tests on this. And number 2, no homework, no lab, no nothing. But I just wanted you to be introduced to it. All right, so again, a delegate is a type that can refer to methods with a specific return type and parameter list. To use it, you start by creating an instance of the delegate and identifying the method it will use. Delegates allow you to indirectly call one method from another. So a common use, as it says there, is to wire an event handler to an event so that the correct event handler is called when an event is raised. So again, this is something we have talked about before. We have. What do I mean? Well, you've worked with events before. As an example, The event we've worked with most often has been the button click event. Another event that we've worked with is, for example, when we used the drop-down list, when we had a change event. We've looked a little bit with radio buttons at a check changed event. All right, we'll look at some more of that stuff in a little bit. So an event, as they say there, is a signal that some kind of an action has occurred on an object. To define an event, it says you start by declaring a delegate that will be used to refer to the event handler for the event. And it says that's the first statement that they're using right here. So declare the event, change handler, and initialize it to null. It says then you code the event declaration as shown. This declaration names the delegate followed by the event name. Finally, the event declaration initializes the event to null and it suppresses any warnings. Okay? So once you've declared an event, you can raise it by referring to the name as shown in the ad. So in other words, when something happens with objects, by default, the system may or may not know what to do. And typically, it doesn't know what to do. All right. Or it may not, what it does by default may not be what you want to have happen. You want an event that happens to be handled your way. And that's what this is meant to allow you to do. All right. So as they mention here on the bottom of page 435, an event is a signal that an action has occurred on an object that was created from a class. To be used by other classes, the event must be declared with public access at the class level. An event declaration specifies a delegate that will handle the event along with an event name. To raise the event, call it by its name and pass the arguments that are needed by the delegate. To handle an event from another class, create an instance of the class that raises the event and assign it to a class variable and run through basically the same thing. All right. Next, give me a second here. We're on 436. All right, we're about halfway through with the chapter here. When we get done with the chapter, we're going to take a very, very short break. So let me go back to 436. All right, it says when you work with delegates, you sometimes can shorten and simplify your code by using an anonymous method. Anonymous methods, those of you who were in the AWD 1000 Web Development Technologies class last semester, we worked with anonymous or unnamed functions. All right, and if you have not taken that class yet, it's something for you to look forward to next semester. All right, in the first example here, it says it creates an instance of a change handler delegate that we saw earlier. But notice in here, you've got product list.change handler my delegate equal. That's the name of the delegate. All right, and it says it's a delegate that does this, but the method itself does not have a name. All right. So if an anonymous event does not require a parameter, you can omit the parameter declaration, so we don't need parens. C# also includes a similar feature to this called lambda expressions. When you code a lambda expression, you omit the delegate keyword and include the lambda operator, which is the equal sign followed by the greater than sign. As it says, is what they show in this first, what is it, the example here? Like this. So here it is using an anonymous method. Here is the same thing using a lambda expression. All right. Now, it's kind of considered that the newer way of doing this is to use lambda when possible, and the older way of using this, all right, is to not use a lambda expression, but just use the anonymous methods. You can get it to work either way, and it's not that one is any better than the other. All right. So, as they mention here, an anonymous method is a method without a name. You can use these types of methods when you create a delegate rather than specifying a named method. A lambda expression is similar to an anonymous method, but it uses lambda operator, the equal greater than. So that's syntax rather than the delegate keyword. All right. The next thing that's discussed in here is how to overload operators. All right. Now, when we look here, these are operators that can be overloaded. What does that mean? I've mentioned to you before that when you are working, if I create an object, all right. So for instance, going back to this example we looked at before, if you remember this, where is it? So I did this, all right. And it didn't like my toString. I don't know why, but it didn't. So let's do this and let's put a tab here. All right. And I'm going to copy this and we're going to make in here Jane Doe. And I'm going to be person one and Jane is going to be person two. All right. So this will have to be person one text, person one last name. All right. Then I'm going to go and grab this and we're going to say equal. And then now we will put in a blank line or another line plus, heck, let's put two of them here. All right, and that'll be person two, last name, first name and last name. So if this works the way it should, I should have on the first line here, Jeff Scott with a space between the Jeff and the Scott. And on the second line, it should be Jane Doe with a space between the J and the Doe. Jane and the Doe, I should say. I guess a tab between, not a space. So let's run this. And what did I do wrong? I didn't use my plus equals. So this has to be a plus equal right there. Now let's try it again. And there you go. Nothing surprising there. It didn't like the \t. So we'll just put in a space there and there. And I didn't need two \n's there. So let's do it one more time. And there they are, Jeff Scott and Jane Doe. We could add as many in here as we wanted to or needed to. But the point is this, that looking at this, it understands everything we're trying to do, but it would make no sense for us to do something like this. We couldn't say something like, I don't know, these are all going to be the wrong types, but let's just say string, hello, equal. We couldn't say like person one plus person two. Right? It doesn't understand what we're trying to do here. It says the plus operator cannot be applied to operands of this class. It doesn't know what we're trying to do. If we want to try to do something somewhat similar to that, we can use this operator overloading. All right. So it says the product class that we looked at much earlier used operator overloading. Specifically, it overloaded the plus and the minus operators so that the user was able to add products with the plus operator and remove products with the minus operator from the product list rather than using the add and remove methods. Why? It may make your code a little bit easier to read and understand. Now, with that said, you're still going to have to do the work to add or remove things in the background for it to work. All right. So, as they mention here, the next figure gives you some basic information about operator overloading. It says first, you should know that you can overload both unary and binary operators. What are the differences? You should know this by now. A unary operator is plus, minus, plus, plus, etc. The point is, all of these operators only work on one operand. So if I've got the number 12, I can say plus 12 or minus 12 or not 12 or plus plus etc. minus minus. These both work on just a single operand. These work on two operands. So there's got to be something to the left and something to the right. But the bottom line is, if you want to overload operators to make them do something they normally cannot do, you can overload any of these unary operators and any of these binary operators. Now, when you do this, what should prevail here is common sense. In other words, all right, you really shouldn't go in and overload, as an example, you shouldn't really go in and overload the plus operator to remove something or the minus operator to add something. It's not that you can't do it, but you're going to confuse people. So why would you want to do it? I should mention I've got stuff in here on events also. And finally, on the operator overloading that we're going to be going over right now. Okay. All right. C# defines the meaning of these operators for built-in types like decimal, int, string, date, time, but not for user-defined types. All right. So some stuff it does understand, like double equal sign. All right. But the plus sign doesn't make sense unless you overload that operator. So as mentioned here on 438, with operator overloading, you can create your own implementations of C# operators that are appropriate for your classes. All right. So in other words, you can make these things either do something different than they were designed to do, or if they weren't at all defined, make them do what you want them to do. All right. So there are some examples that are in here. And if we look on the bottom of page 439 here, you use the operator keyword to overload an operator within a class. And they give you a couple of examples. You can overload any of the unary or binary operators that are shown. And there are some that aren't shown in the book that you can overload as well. Overloaded operators are always static, so they can deal with null operands rather, in a correct manner. All right. When you overload relational operators, like the double equals or the exclamation point equals, you need to provide your own version of equals and get hash code methods, as they're shown right here. So the next figure shows you how to overload those arithmetic operators that we talked about. So for instance, the plus operator so that you're able to add a product, the minus operator so that you can remove a product, etc. And they show you how to do this here. Right? Now, in the background again, you're still doing what you want to do. So it says part of a product list that overloads the plus operator. So if you do set it up so that it uses the plus operator, it still is going to do the add. All you're doing is typically what this is referred to, and I don't know if this is a great example of it or not, but a lot of times when you read about different things that are done online, people will talk about things like that are referred to as like syntactic sugar. All right. And it's what that is it's a way, it's a syntax that you can use to make things easier to understand. All right. Because it might be easier to understand the plus sign here than doing it another way. All right. So you can overload the built-in arithmetic operators so they perform customized functions. You should only overload those operators that make sense for a class. You don't overload the plus equals or minus equals separately. Rather, they're handled automatically by the overloaded plus and minus. All right. And an expression that simply returns, or an operator that simply returns an expression or executes a single statement can be coded as an expression bodied operator. So something that looks like this. All right. This as opposed to this. Okay. All right. You can also, as it says here, overload relational operators. Relational are the greater than, equal to, greater than or equal to, not equal to, less than, and less than or equal to. All right. Says figure 1311 shows that relational operators are often more difficult to overload than arithmetic operators. Okay. So if we look on the next page, there are some examples there. And as they mentioned on the bottom of the page here, if you overload the double equals, you must also override the non-static equals. We already talked about that one. Before it calls the equals method, the overloaded double equals operator should test for null values. Relational operators are always implemented in pairs. And when you override the equals operator, you must also override the get hash code method. All right, we're just about finished with this. So the chapter ends with them creating an enhanced version of the product maintenance application. So it says, now that you've learned all these techniques for enhancing classes, the topics that follow present an enhanced version of the product maintenance app that use these. From the user standpoint, it works exactly like what we had in chapter 12. However, the classes are implemented differently. Specifically, it says it uses a product list class that includes the additional members that are shown in figure 13.2. So it's all the stuff in mustard yellow. So you can see we've got a delegate in there and an event in there. And you can see in here how we're using the delegate. And there's an explanation. Again, I don't want to go over any more of it than I already have. All right. It ends here with going over the product maintenance form, and I'll let you read that on your own. Now that's it. So even though that wasn't what I'd call super extensive, you've had close to an hour on this. And again, you can go back and take a look. Here's the operator overloading. So I gave you a bunch of places in here and things that you can conceivably take a look at least get you started on your way with this. So we have now completed both the chapter 16 lecture and the chapter 13 lecture. What I'm going to do next is we are going to complete the 2 inheritance programs that have been attached to your email. Now, I gave you this today, and it's in a folder, and in that folder, we've got a thing in here that's called LB1 letters. Terrible name. But what I'm going to add right away here is I'm going to open my git bash, and I'm going to do a git init here, so we've got that in here. All right, there's our empty Git repository. And I'm not going to do anything else. I'm not going to do an example or anything else. But what I am going to do before we take the break, just so we have it, is this is called inheritance examples. So I'm going to go out to GitHub. And I'm going to go and create a new repository. that is going to be called inheritance examples. That's what I'll save for you today. All right, create the repository. So let me go in here and grab my remote origin line from right here, copy that to the clipboard, come back over to here. This we don't really need anymore. So I am going to comment that out, do a file, save all, close that, and then come back into here and into here and paste that in. So if I do my git remote -v, it is set up now with my inheritance examples repository. All right, it is 9:15. I'm literally going to take 5 minutes because I want to go and get myself another water. All right, and then we're going to go back in and we are immediately going to start by going over this EX1 letters, and then we will do the EX2 photos. All right, see you in 5 minutes. All right, it's 9:20, so I'm going to continue on. Again, if we look today, what I hope to do in the next hour to 2 hours is to do this, and that is to complete these two inheritance problems. All right. And if today we get nothing more done than these three things, and then, so if we get that done by noon, and then we can do that afternoon in a private video, I'll be okay. Then tomorrow we would have to do these along with our other stuff, but we'll see how it goes. All right. So let's take a look at this. There are two applications on here. The first one is called EX1 Letters. Create a GUI app for a letter delivery service. We are assuming letters, as it says, cost 50 cents for you to send. If you want to send a letter that's certified, it's an additional 15 cents and it must have a tracking number, meaning that there is some way to track it. That's the certifiedness. A user can send up to 10 letters, all right, which means that we're having a limit in here. Every time a letter is sent, it'll be added to the top of a transaction log. Store the list of letters sent in a single array. We want to use an array here as opposed to using a list, because remember, with a list, it'll just automatically expand. So we really can't just set it up to hold 10. If the letter does not include a tracking number, then we want to make sure we instantiate a letter object. If it does include a tracking number, we want to make sure to instantiate a certified letter object. So this is what we have. All right. So what this means in here is we're not going to do anything with this because everything comes off of object. An object has a virtual toString method in it, but we are going to override the toString method. So right now, when you look at this, what we're saying is letter is an object. Certified letter is a letter. So when we look in here at what's in here, letter is going to have two instance variables, a string, which will be the recipient, so that's whoever the letter was sent to, and sent date, which is a date time object. All right. You'll notice that we have one constructor here, and it is a full arc constructor, which takes in both the recipient as a string and the sent date as a date time. In addition, we are going to override the toString method in here. Finally, we're going to set up just getters for the string, the date time, and the price, meaning these are going to be set. We're not going to be allowed to change these because there are no setters in here. All right. You have to start to learn to understand how to read these. Now, the pound sign here means these, the recipient, etc. in here, and the sent date, all right, that technically they should be put in there as protected. Both of these have plus signs, so they're public. Both of the, or all three of these have plus signs, so they're public. Tracking number has a protected string in it. All right, it's part of the certified letter. So notice that it's going to have a recipient and a sent date, but those are both going to be handled by the base constructor or by the letter constructor. This will only handle the tracking number. It will again override the toString method. So rather than it being 50 cents, it'll be 65. The tracking number will be set up basically again as a getter, as will the price. So this is our interface. I sent you this. So I'm going to open this up right now. So this is actually what I sent you. This is from the inherited examples. This is what I'm going to be working with in here. So right now in here, if we take a look at our first example that's in here, once it comes up, that's the second one. So let's close that. And let's close that. We will set the current project, startup project to the first one. And right now it looks like this. I gave you the user interface. You have all this. All right. So again, if we put a tracking number in here, it's going to be 65 cents. If we leave a tracking number out, it's going to be 50 cents. You can see the names of all the different controls that are in here. There they are. All right, so everything has been marked, so to speak. But right now, the send, the clear, and the exit, if we take a look in here, come on. I put in the comment that you had from the page, but all right, in the load event, there's nothing in there. The send is empty, the clear is empty. We've got our exit, but I just grabbed what we've been using. I grabbed the show message. All right. So right now, if I run this, I can put in information. But when I click send, nothing happens. Clear, nothing happens. And exit will allow me to exit the program. All right. So let's start, so to speak, at the beginning. I'm going to try to make a class library in here. So I'm going to right mouse click. I'm hoping this works. On here, I'm going to choose add new project. It will be a class library. We'll call it letters library. All right. And going to next, I'm going to again make this 2.0 and click create. And I'm doing that to make compatibility with the form file. So there it is. All right. Now, I don't want to use class 1. I'm just going to get rid of this. So in here, I've got class 1. I'm going to remove it. I could just rename it, etc. I'm not going to. It's gone. So now in my class library, which again is called letter library, I'm going to right mouse click. Don't need that. All right, I'm going to right mouse click on there, choose add, and go to class. All right, the first one will be our letters class, or our letter class. So there that is. I'm going to change this to public, as we always do. All right, so public, there we go. And we were told in here for our instance variables, we would have a protected string, which is underscore recipient. And we will have a protected, I think these were both protected. Let's double check. Recipient and sent date, both are protected with a pound sign. So that is of type date time, and we'll call this underscore sent date. I'm just grabbing that right from our specifications. All right. Then we had a constructor here. I'm going to call this full arg constructor. I am going to save this so you will have access to this. All right. Hopefully this will give you some help when you take your test on Thursday, because there'll be multiple classes in there. So public letter, whoops, letter. And you'll notice it's already trying to help me here. Like that. So the IntelliSense is kicking in basically. Just like that. So I now have all of my information that I need in here. All right, for my constructor. So now I need my getters. And I'm going to use the newfangled way of doing this. So I'm going to say public string recipient and the date time, but I don't want it to say received date. I want that to be called sent date. All right, so we've got those. We've got our getters now. So we came in and based on our specifications, we created two protected instance variables. Remember the difference between public and private and protected. Public means that it's available to anyone. Anyone can look at it, anyone can change it, etc. Private means it's only able to be, I don't know what the word I'm looking for is, but utilized within the class itself. Protected means that it's going to be able to be utilized within the class itself and any child classes. The reason for that is these are protected. So if we want to change them inside of our certified letter class that we're going to be creating in just a couple minutes. All right. With our full art constructor, now that I look at this, I'm missing something. That's like me. So underscore sent date is equal to sent date. All right, so there is our full art constructor that has both in here, both of our instance variables in it. And here's our getters. All right. Now we have to work on the price and we have to work on our toString method. Okay. So this isn't, I guess you could call this a getter, but we don't want to just say public decimal price 0.50M like that. No, because that would say the price is always going to be set to 50. We don't want that because if it is a certified letter, we want it to be 65. So we want to be able to change this. We want to be able to override it. But to let the system know we want to be able to change it, we have to put the word virtual in there. All right. Then finally, we want to come in here and we want to override the toString method. All right, so that'll be a public override string to string. All right, and we do want the word return in there, but we want to return the date, so sent date dot toString, and we'll put that into a format. So we'll put that into MMDDYYYY format. All right, so we'll put that in there, plus, and we'll have a blank space, plus, and then we want the recipient, all right, plus, comma, in a space, plus the price dot toString currency format. All right. Now, all we're saying right here with this overridden toString method is we want it to basically look like this. So there's our sent date. I guess I didn't put a comma in there, and I should, with a comma and a space, and then the recipient with a comma and a space, and then the price in currency format. That's it. Now it's going to change when we do the certified letter in just a moment, because with the certified letter, it'll also need the tracking number there. All right. But we've now completed everything in our letter class, except, as I mentioned, after the date, I will put a comma and a space because that's meeting the specifications. All right. So that right there, and again, you'll get this. You will get all of this stuff, and I don't really need that. But there's our letter class right there. Pretty short, about 30 lines. So let me do a file save all. All right. Now let's go in and let's create our certified letter class. All right. So again, I'm going to right mouse click on my letter library. I'm going to choose add and I'm going to choose class. All right. Well, maybe I didn't choose class, but we'll choose class up here. How's that? And we're going to call this certified letter.cs. All right. Now, the first thing to change, as always, after we get rid of that, we'll be changing this to public. All right. But we want this to make sure the system knows this is a child of or inherits from letter. Now we're getting errors, but the reason we're getting errors is there was stuff we set up in letter. I think we're getting that because of this. There we go. Did I spell certified wrong? Yes, I did. So let's rename this as certified letter. All right. And I think it changed everything. Okay, it says we're not using the recipient. Okay, and we're not using the sent date. We're going to put that in right now. So don't worry about it. We will have one new instance variable in here. And that will be our protected string, which is called tracking number. All right. Then we will have our full arg constructor. So that'll be public certified letter. And we'll have string recipient. Whoops. I'm going to put these on separate lines so you can see exactly what's going on. Date time. And that's the sent date. And now string for the tracking number. All right. But we'll have to do that as well, because we're going to say in here, what we're saying is we want the parent in here, the parent or base, to handle the recipient and the tracking number for us, because that's what that constructor does. All right. So it's giving me an error now because I need the curly braces. There we go. And yeah, all we need to handle here is the tracking number. That's it. All right, we're not done yet, but we're getting there. Now, if you remember in the letter, the next thing that we did in here is we set up our getters. And then we put in the price, but we made it virtual so we can override it. And we overrode to string. So we want to basically do the same stuff in certified letter. So we want to come in here and I want to put in my getter. All right, so there's that. Now we want to override the price. And again, this is only going, whoops, try that again. Let's see, override the price. Decimal price. I don't want to do it. I can do it like that, but I'm going to do it like this because I think it makes more sense. All right. And now we want to say get return 0.65 M. Because remember, if it is a certified letter with a tracking number, it's 15 cents more. So previously, we just did this. And we could do it the same way there as we did it here, but just say public override decimal price. I think that would work at least. So I think we can also do that like this. I'm going to comment it out because otherwise I'm doing it twice. And this would say override price, and this would say 65. So I think if I comment this out and I uncomment this, that it'll still work. And it does. So you can do it either way, is what I'm telling you. I'll leave them both in here so you can see them. All right. Now, when we look in here, we want pretty much the same stuff. We want the cent date. In fact, we want everything that's in here. So we could go and copy this. We could go in here and copy this. Again, I'm doing this for a reason. So I'm going to override the toString method, and I'm going to show you two ways of doing this. All right, so override toString. But once we get down to this, I can now say plus, and again, comma space, plus tracking number. Okay, you'll notice no errors. It'll work just fine. But we don't really even have to do all that stuff or do it exactly like that. All right. Why? Because really what we want to do is what is handling in here? Really in here, what is handling and doing it like that? I'm going to say base dot there, and I'm going to say base dot here, right? But I'm not going to say base dot here because we overrode that. All right. So there is our certified letter class. And I showed you in here more than one way of doing something. So some people like to do it this way because it really and truly kind of expresses everything that's going on in here. Other people don't because to them, it's more work. And I understand both points of view. I really do. All right. So let's go back. I'm going to do a file, save all in here. I'm going to keep open my certified letter and my letter. And now I'm going to go back to my code in here. All right. We've already done the exit. When we clear, what do we want to do? All right. I'm asking you this question. When we click clear, what do we want to do? All right. Well, we want to clear this. We want to clear this. We want to clear this. We don't want to show that because we don't know if it's certified or not. So 1, 2, 3, 4. Then we want to put the focus here. Not real much. So we'll do our clear all. And again, txt recipient dot text equal double quote, txt sent date dot text equals double quote, txt tracking number dot text equals double quote, LBL additional fee dot, we're not going to make this visible. So dot visible equal false, and txt recipient dot focus. So that's what we want to do when we clear. All right. Let's quickly look. So file, save all. All right. So I can still put anything I want to put in here. Now clear should work. This should clear. That should clear. That should clear. That should clear. And our cursor should be put in there. Looks like everything worked to me. Exit we already know works. We did that before. All right. Now, what I'm about to show you is I'm going to put in the code now. I'm going to say this again. I'm going to put in the code now for the send button. But before we do, I did put in some stuff up here. So let's come in here and I'm going to put in a global constant. And a const int, and I'm going to call this total letters. And I'm going to set that equal to 10 because that's what we were told to have, was 10 total letters. And I'm going to set up some global variables as well. So I'm going to have a list of type letter. I'm going to have a list of type, that's going to give me an error, but we're going to fix it in a minute. A list of type letter, letters. I'll fix that in just a minute. And it's going to be a new list. All right. I'm going to put all this in there and then we'll go back and change it. Okay. So this will say total letters. Like I said, don't worry. This is going to all change in a minute. And I'm going to make a list of certified letters. Again, it's giving me errors. We're going to fix it in a minute. I'm going to have a string array in here that's going to be called sent letters. And that's going to be equal to a new array of type string. And the max size again will be total letters. All right. And then finally, I put in here an integer that I called num elements. That's how many things I currently have in here. What happened there? Set that equal to 0. Move that over. And finally, I'm going to have a date time that we're just going to call sent date. Now I could set that equal to null or the date dot now or whatever. I'm not going to. Now this, I want this to say letter. Want that to be called letters. And I want to set that equal to a new list of type letter. All right. And you'll notice I'm getting all these errors. And I'm getting all of these errors because it's not recognizing my class library. So let's see if we can make it do that. So I'm going to click here. I'm going to go down, add reference to letter library. All right. And you'll notice using letter library, that fixed this one. So what about this one? Well, remember, we have two classes in there. So I'm going to come into here and I'm going to say, what does it like? Oh, it's because I spelled it wrong. That should be certified. There we go. Now everything's working. So I was able to go in and create this class library. All right, I created in here this class library that we called letter library. And that letter library has in it letter.cs, certified letter.cs. And now we are bringing those in to our program. All right. Okay. I tried to come in here and put in a lot of comments so you're going to be able to see, hopefully, everything that we're doing. Hopefully, like I said, you're going to be able to see everything that we're doing. All right. As we get started. So the first thing is in the load. I wanted to make sure when the program first loaded, maybe you remember this, maybe you didn't. That showed. That really shouldn't show. We don't know yet if we're sending a certified letter or not. So inside of the forms load event, I'm going to set that equal to false, which means now that should not show. See that? All right, that's what we wanted. So that's the first thing. And it may not sound like a big thing, but again, we're trying to write this in a way that if somebody is running the program, ideally at least, it's going to make some sense to them. All right, so the first thing we want to do in here, and we're going to be calling a bunch of routines we haven't written yet. So I'm going to say validate recipient text box was not empty. And again, we can use try catch, we can do all those goodies, but for now, I'm just going to use the old bool, keep going, equal validate recipient, which hasn't been written yet. So we'll put here private bool validate recipient. Okay. Now it's giving us an error because we're not returning anything yet. That's okay. All right. So let's validate the recipient. We're actually going to have to validate that that there is a recipient, that there is a sent date, and that there is a tracking number. All right, so we're going to put this as, I'm going to change this to is valid recipient. We'll call it that. Okay, just like that. All right, well, how do we know this? It's pretty doggone easy. We're going to do this very similarly to the way we've been doing this in the past. So bool retval equal true, retval equal true, and if txt recipient dot text dot trim, if it's double equal to nothing, well, we know that there's nothing in text box, nothing in the recipient text box. So what are we going to do? We're going to call our show message. I think, did I do that wrong? Yep, that should be a big S. So we're going to call our show message, and we're going to say recipient name cannot be empty. And our message will be recipient field empty. All right. And if it's empty, well, what do we want to do? We want to say txt recipient dot focus. And we want to set retval equal to false. Finally, we want to return retval. There it is. That's our first one. We're going to write two more that are similar in just a moment. But before we do, let's see if we can test this one. So file, save all. We're going to leave that recipient text box blank. Recipient field empty. Recipient name cannot be empty. And there's our cursor. So that's working. All right. I'm going to put another one right down below it. All right. So right here. And I'm going to call this is valid, not recipient, is valid sent date. All right. And I'll leave this in here and I'll just leave it all in there like that. Okay. So we did this bool. If keep going, well, what do we know? If it was keep going, there was a value in the recipient text box. All right. So now validate there is a value in the sent date text box. All right. So keep going is going to be equal to validate I'm sorry, what did I call it? Is valid sent date. Like that. Now, if we get down to here, if there's an else, what do we know? Nothing in recipient text box. So I'm just going to return. Pretty similar to stuff we've done before. So we now validated. So again, if we run this and we leave it empty, boom, and we're dead in the water, so to speak. Okay. If we do put something in there, we don't get an error, but nothing's happening because we haven't told it to do any more than that. So we want to validate the sent date. All right. Now there's a little bit more work here. First of all, we want to make sure it isn't empty. All right. So here there's nothing in the sent date. All right. So sent date cannot be empty. All right. So sent date field empty. So we should now be able to check for that one. So now I'm just going to put garbage in here. But if I leave that empty, sent date field empty. Sent date field date cannot be empty. Good. I've got that done. All right. The other thing I want to do is make sure, of course, that that is set to sent date. All right. So if we get down to here now, there was something in the sent date text box. Now verify it holds a date. All right. So I'm going to put in here, we put our bool in here of retval. Let's put another bool in here that we're just going to call result. We won't initialize it. So I'm going to come in here and say result equals, this is the first time I think we're doing a date time dot try parse. And we are doing it on txt sent date dot text. And for our out, it will be sent date. And that sent date that you see right here, we define that up here at the top of the program. I just made a bunch of globals here. Maybe that wasn't the best practice. It's the way I did it. So we want to come in here and check for non-date value in the sent date text box. So if not result, this is all stuff we've done previously. So if not result, we want to call show message and say invalid sent date entry. And we'll put in here sent date field contents invalid. All right. And now there was something in there. So we want to say txt sent date. We don't want to just set the focus. We want to say dot text is equal to nothing. Now we want to set the focus. Put an equal sign there. And we want retval equal to false here as well. Finally, we want to return retval. All right. And I spelled try parse wrong. There we go. So now we also should be set for an invalid date that's in there. So you've already seen this. There's nothing here. Recipient field empty. Recipient name cannot be empty. Boom. We come back here. We put something in. Now sent date field empty. Sent date cannot be empty. And we're getting an invalid here as well. I'm not sure why we're getting that, but we'll fix that in a minute. But if I put something in here, hello, sent date, field contents invalid, invalid sent date entry. All right, and it does clear it and put the cursor there. All right, we're almost there. Okay, so when we got down to here, there, if keep going equals this, otherwise this. So again, there was a valid date in the sent date text box. All right, so again, if keep going, well, we want to now say keep going equal, well, what else do we have to check? All right. We have to check and see if there is a tracking number. So I'm going to call it just that. Is there a tracking number? I'm getting an error because, again, of course, that has not yet been written. Finally, else return. All right, I don't like it like that, so I'm going to put it like this. Okay, we're not done yet, but we're getting there. So again, this will be another, I'm sorry, private. And this is our, is there a tracking number? Pretty small. So bool ret val equal true. If we just remember that's a string, so I'm just going to say if txt tracking number dot text dot trim is equal to not whoopsie is equal to nothing, ret val is false, but we also should do a show message there. And it will say tracking number blank. Actually, let's see. No, I'm not going to put that in because if it's a non-certified letter, it's going to be blank anyway. So we'll just say here ret val equal false, and we'll return ret val. All right. So when I come back up to the top here, or near the top, we have validated that there was a recipient. We have validated that there was a sent date. And we have checked to see whether or not it was a certified letter. All right. So if this returned true down here, if this returned true right here, if it returned true, there was something in the tracking number, so it's a certified letter. All right, so if keep going, now right here, there was a tracking number, so instantiate a letter object. So that'll be my if. But I'm also going to need an else here. There was not a tracking number. So instantiate a letter object, and this one's wrong. This is a certified letter object. And I decided to basically, for lack of better words, call it what it is. So if there was a tracking number, I'm going to call instantiate a certified letter object. All right. And if there isn't, I'm going to call instantiate a letter, a letter, come on, letter object. All right. I'm going to comment this one out for right now. All right. And let's work on the other one. So let's instantiate the letter object. All right. We're actually pretty far into this program already. So private void. And while I'm at it, I'm just going to add the other one too. So this will just be instantiate a letter object. So now I can go back up here and where I commented that out, I can uncomment it. And I'm not getting any errors. In fact, I'm not getting any errors on my whole program right now. That's a good sign. All right, but I'm going to put a comment down here. All right, so in fact, let's put comments by all of these. So I'm going to say here, validate that recipient text box not empty. Because that's what we're doing there. Here, we're going to validate that the sent date is not empty and that the text box holds a valid date. All right. And finally here, we're going to validate that the tracking number text box is not empty. Okay, just trying to put a few comments in here. So if we get down to this point right here, what do we know? We have validated that number one, the recipient text box was not empty. Number two, the sent date text box was not empty. Number three, the tracking number text box was not empty. And number four, all right, let's see. That should actually be number four, so let me. Here that the sent date text box holds a valid date. So what we know is either we want to create a certified letter object right now, or we want to create a letter object. And it's going to be pretty similar, the logic. All right. But the first thing we have to do is we have to see if there's room. Remember, we can only have a max of 10 letters. So first thing I want to do is make sure that there is, we'll just call it room for a new certified letter object. All right. So if the number of elements, remember that's how many letters we currently have, is less than total letters. All right. So if there are less than 10 letters in there, then what can we do? We can instantiate a new certified letter object. So certified letter, we'll just call it CL for certified letter, equals new certified letter. Let's put this on a new line so we can see everything. We want txt recipient dot text. We want that sent date because that's been formatted, and we want the tracking number. Okay, that should allow us to go in and instantiate and create a new one. All right, that's okay. We're still not done yet, though. Next, we want to add the new object to the certified letter list. Remember, we have two lists. So we're going to say certified dot add. We want to add CL. So we're adding it to the right one. All right. We also want to add the object information to the TXT letter history text box. And that is, we want to add it to this. All right. We want to say plus equals. We don't want it to overwrite. We wanted to add it to it. Now notice we can use the toString. Plus, and since this is going into a text box, we need to say \r\n. So that'll give us a new line. All right, we're almost done. So let's see, what do we want to do next? We want to add the information to the string array. That's dot text dot split. All right, I think that's just got to be a \n in there, not an R and N. And yeah, we're doing it based on a single character. So there we go. We want to make the label visible. And finally, we want to add 1 to our total number of elements. Now we're going to be doing kind of the same thing with all these. So I think I'm going to be repeating some text. in here. So I really could have probably put those into their own routine. I did not do that. Otherwise, we'll do a show message that says no more room for letters in the list. And we'll say list is filled. Plus, we will take that LBL additional thing, not visible, and make it false. All right, that's everything. So we actually should now be able to go in and add a certified letter. I think at least, unless I've got any mistakes in here. So if we come in here now and the recipient, let's say gas company. Sent date, we'll make it today. So 7/10/2023. The tracking number 1233456. Send. All right, I get the additional fee. I get 7/10/23, comma, gas company. It is 65 cents. There's the tracking number. If I clear, all that clears and I'm back to there. Now, it's not going to yet handle the regular letter because we haven't written that routine yet. So instantiating a letter object. Now I'm not going to re-add this stuff. Other than to put this one in here. And I can say the tracking number text box was empty. All right. So very similar to what we just did. I'm going to grab a little bit of this stuff here. In fact, let's grab everything. All right, but we're going to have to make changes. So make sure there is room for the new letter object. Instantiate a new letter object. We won't want this tracking number. Now notice we're going to get an error if we remove that tracking number. All right. Why? Because a certified letter is expecting one, but a letter is not expecting one. So now my errors are all gone. So now I have to add letter. So instantiate a new letter object, add to the letter list. So this is letter, letters.add. I guess I should have called it probably letter, but it's okay. Add it to the letter history text box. That'll be the same, but it'll be L. Add it to the string array. That looks good. Make the certified label visible and add 1 to our number of elements. Otherwise, there's no more room. The list is filled. So we can take, it's saving a little bit of code. So I can take these 3 lines here. I'm going to make a thing called either letter type. And I'm going to add the info and do everything that I wanted to do. So down here, we can call either letter type. And up here, we can replace all 3 of these with a call to either letter type. It saves a little bit of code that way. All right, a little bit of repetition on my code. All right, well, let's see if this works now. And we'll put in a combination of both types of letters. All right. So no errors. That's always a good sign. Remember, we should only be able to add 10, and we're not saving them. We're not working with files or databases. So I'm going to say gas company 7/10/2023, tracking number 12345 6. There's one. Oh, it's doing both. All right. Well, something's wrong there. That should be an else. We don't want to create both types. So let's try that one again. So this will be gas company 7/10/2023, 12345 6. There that is. Okay, that looks good. Let's clear. And let's say we wrote a letter to mom, was yesterday, and we'd have, it wouldn't be certified. So there's mom. Ooh, that should not be showing. All right, I'll have to check that. I'll fix that, but I want to keep going here. So let's put another one to mom, 3/4/5/6. And now let's put in a couple more. So now we have 1 2 3 4 5 6 letters, and we'll put in cable company 33333. Got that. Let's say we again and again. So now we have 1 2 3 4 5 6 7 8 9. Let's say I have one to dad, and it had nothing on it. So there's 10. Now, if we try again, we shouldn't be allowed to because we have 10 already. No more room. Even if we gave it a tracking number, still get the error. That's good. All right. Everything appears to be working except this is always showing. We don't want that. So where we have this instantiate a letter object, the first thing I'm going to put it, whoops, first thing I'm going to put in here before I even check to see if there's room, I'm going to say LBL additional fee dot text is equal to nothing, even before I check anything. All right, so now if I do put in here mom 6/6/2023, hit enter, now I don't get that message here. Okay, but if I change that to electric company and I do put in something, oh, now it's not showing. All right, so let's take this. In fact, here where I said dot text, I don't want to say text is equal to nothing. I want to say dot visible is equal to false. And if it was certified, I want to come in and say that the visible is equal to true. So I'm not going to put 10 in again, but again, cable 7/7/2023. That's in there, and it's in there like this. Brother, that is still showing, and that should not be showing. It's calculating correctly, but it's showing that, and it shouldn't. Well, one way I can be sure that that happens is after it does all that, after it shows everything, where is that? My to string here, either letter type, I can call clear all. That should clear it all out. Let's try that. Mom, 7/7/2023, hit enter. There it is, and it cleared. That's good. Cable, 7/20/2023. Now it is actually showing, but it's clearing so fast. Ah, I'm going to leave it the way it is. You can play with that if you want to. Okay. All right. So very quickly, we came in here, and in here, we set up two global lists, one to hold our letters and one to hold our certified letters. These are all of the sent letters. This is how many letters we've sent. This is the date time we put in there that's been formatted. We want to make sure this is not showing when this loads. I could just go in there and make it show all the time or not have it or do whatever. But we validate there is a recipient. We validate there was something in the sent date. We validate that there was a tracking number or not. If there was a tracking number, we instantiate a certified letter object. If there was not a tracking number, we instantiate a letter object. The is valid recipient and the is valid sent date are pretty much what we have been doing all semester. Nothing new there, but we did do in the sent date, we did do a parse on a date time field, which I don't believe we've done before. All right, so let's see. Then for the tracking number, again, just seeing if there's something in there or not. If we get down to this point, as it says, we have validated that the recipient text box was not empty, that the sent date was not empty, that the sent date also holds a valid date, and that the tracking number text box was not empty. If we get to here. All right. So we basically come in and say, hey, and that's why, I mean, this is showing. I could set a timer or something in there, which I probably should do, but I'm going to leave it the way it is. All right. Be a nice thing for you to try to do if you can. All right. Is there room? If there's room, we add it. We add it to our text box on the right, kind of clear the stuff up, and then we call clear all. Again, that's where you'd put the timer, would be here. You'd maybe wait 2 or 3 seconds and then time it. Pretty much the same thing for a letter object, except rather than putting in the recipient, the date, and the tracking number, it's just the recipient and the date. Other than that, we're doing the same stuff. That either letter type, it just basically said instead of typing that in and having that in there as, we'll count the comments, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. As opposed to 22 lines, it's now 11 lines. All right. There's our clear, there's our exit, and that's everything. Again, along with our using letter library at the top. All right. So that is the first one. So we have now done the first of two that I wanted to do today. So let's look at the second one. So file, save all. I will tell you the second one is harder. All right. The one with the photos is harder. So let's do one more file, save all on here. All right. And let's close everything we've got for letters. And let's take a look. We're going to create another class in here in just a minute called photo library. All right, and it'll be a class that'll hold 3 photo classes. Let's first take a look at what those particular classes actually are. So let's do that first by taking a quick look at the requirements. So we just went through this one. I'm not going to run through that anymore. This one, write a GUI application for a photography business. 8x10 photos are $3.99, 10x12s are $5.99. Anything else is $9.99. Customers can have either a mat, kind of like a piece of cardboard, basically, that the photo is on, or a frame. Matted photos are an additional $10. Frame photos are additional $25. All right. Override the two-string methods on the photo, matted, and frame so that they display all field information. So this is a little, like I said, a little bit more complex. A photo class has got two protected fields, a width and a height. It has a full arc constructor, which takes in a width and a height, and it overrides two string. It also has two getter and setters, the width and the height, and one getter, the price. So that's our photo class. It has two children, a matted photo and a framed photo. The matted photo has a color that's in there. All right. And notice it's of type color. All right. We're going to use an enumeration in here, even though we haven't really done any work with enums. So it can have a black mat, a red mat, a green mat, a blue mat, or a white mat. And you might look in here and say, why aren't those numbers contiguous? They could have been, but the reason that they're not contiguous is we would now be able to add other colors in between there if we wanted to. All right. We also have a framed photo class, which has material, which again is of type material. It's another enumeration. So the frame can be made out of pine, oak, steel, silver, or gold. And we have a style, simple, modern, antique, vintage, or eclectic. A frame photo has a width and a height, whereas a matted photo has a width and a height, but a matted photo has a width and a height and a color, and a frame photo has a width, a height, a material, and a style. They both override the two-string method. All right. And a matted photo has a color with a get set and a price with just a get. A framed photo has a material with a get set, a style with a get set, and an overridden price with just a get. All right, so we should be able to print out something that looks like this when we're done. All right. So again, what I did here was coming into this, not letters, I'm sorry, photos. I don't want letter library. But if we look in here, this is our GUI. Now, if we choose unframed, all right, then really when you think about it, I think we should not be able to check any of these. If we choose matted, we should be able to choose any of these, but none of these. And if we choose framed, we should be able to choose one of these and one of these, but none of those. When we click calculate, it should give us the price here. All right. And what am I missing? Oh, the information also. So that'll be the price, and that should be the information about what we're buying. All right. Now, I came in and made I just said I'm assuming that the biggest photo would be 72 by 72, 6 feet by 6 feet. All right, maybe that was stupid, but that's just the way that I did it. All right. So I'm going to come in here, and the first thing I'm going to do just for a second is I'm going to close this, and I'm going to go in and add another library. And we'll call this photo library. There is nothing that says that when you use, and make sure it's 2.0 again, there's nothing in here that says that when you do this, you have to put the word library there. All right, it's a class library. I could have put photo class library or photo class or whatever. All right. Again, I don't want this class one, so I'm going to get rid of it. All right. And now I'm going to come in and I'm going to create my photo class. I am going to create my matted class, and I'm going to create my framed photo class. All right, so let's start at the beginning. So let's start with the photo class. So I'm going to, where I've got photo library, I'm going to right mouse click, add class, and I'm going to call this photo.cs and make this public and start putting in there our stuff. So I believe that these were both protected. Yep, that is, and that is. Okay. Let's put our comments in here. So we've got our width and our height. Depending on your point of view, telesense is either a great thing or a really terrible thing. But for right now, because it's helping me get this done, I think it's a great thing. All right. Then we need our getters and our setters. And again, we'll use the newer way of doing this. And there's so many different ways of doing it. You know that already, but all right. So we've got all that done. So the only thing that's left to do is to override our toString method. All right. And I'm just going to return, spell return, with plus so that'll just say something like 3x5 or whatever. All right. Now that I'm looking at that though, there's nothing on here. I guess I didn't do the price here. So that's just going to return width and height. All right. That's pretty simple. Again, I think I can get rid of these. Width and a height, width and a height, width and a height, and there's that. All right. So file, save all. All right. So that's our photo. All right, next, doesn't even matter the order, but let's do our matted photo, was the one that was shown next. So I'm going to add another class called matted photo. I will tell you, now this is my opinion. You may or may not agree with this come Thursday. This is a much harder problem than what you get on the test. In my opinion, you may not agree when you take the test, but I think it is. So let's first do our color enumeration. So public enum color, we're creating a new data type right here. So black equals 0, red equal 1, green equal 2, blue is actually equal to 4, and white is going to be equal to 7. And again, because you know how quirky I am about things, There's that. Okay. Next, we will have our instance variables. And I think there's only one. It's going to be color. I just called it the color. Our constructor. So there's the three things that we want in there. However, the width and the height will be handled for us, and they'll be handled by the photo class. So the color, let's just call this C, and everything else is just one letter. So let's put in here the color equals C. All right, that's pretty good. We need our getter setter. Unlike something here. Yes, it does. Width and height, width and height. I think it may not like that. Nope, that wasn't it. All right, we'll look at that in just a second. Well, let's see. Public matted photo, decimal W for width, decimal H for height, color C for our color. All right, colon, base, width and height. So oh, I didn't say that this inherited. Matted photo inherits from photo. That should get that error out of there. There we go. All right, let's do our getter and setter. And this will be a public color, the color. Could have just called it color too. I mean, well, that's actually what we call the enumeration. We could have called it probably a better name than the color, but it's all right. All right. We don't want that. We want base dot toString. We actually do want that. Plus matted plus the color dot toString. Okay, and I think when I did the other one, I may have put that in parens. I can leave it in there. It doesn't hurt anything, but I really don't need the parens. Okay. All right. So there was our photo. Here was our matted photo. Do a file, save all. And what we have left then is the framed photo. And that has two enumerations in it. So let's go in and add that one. So in this photo library, we have now added a photo class and a matted photo. So I'm going to come in here and add again another class, and this will be framed photo.cs. There that is. Again, probably don't need these. and public. And again, this, I'll do it right away, inherits from photo. Giving me those errors because it's looking for a width and a height that we haven't put in yet. So first, let's put in our enumerations. We do these. There's 0, 1, 2, 3, 4 for both. 0, 1, 2, 3. Okay, again, let's pretty this up a little. Oops. So there's that one. We're still getting the error because again, we don't have a height or a width. All right, but we now do have our enumeration for our style, for our material. We need another one for a style. Let's just grab the one that's here and manipulate it. So we will call this style. And this will be simple, modern, antique, vintage, and eclectic. All right, so we've got those done. We're still getting our error. And if you look, it says we don't have anything that has a width in there, and it'll show us the height too if we fix that one. So let's start with our instance variables. And did we make these? Let's see. That should have been protected. And those should be protected, and they are. Okay. So instance variables. And again, I could have called it material, but for whatever reason, I called it underscore the material. And I don't know why there's a P there, but there is. And protected style, the style. Right? Let's do our getters and setters. In fact, let's do our constructor first. Okay. Again, we need the material here and we need style. The other ones are both, I'm getting the error because the other ones have to both be handled. The width and the height have got to be handled by the parent. Okay. So the only thing left to do is to override the toString method. So we want to return base dot toString plus plus framed plus the material dot toString why is it doing that? We'll fix that in a minute. Plus, so what doesn't it like here? Oh, I did not. I've set the instance variables, but I did not set the getter and setter. Let's do that. There's the constructor, so let's put in the getters and setters here. Okay. Now I should be able to put in the material here. All right, plus the style. And I believe the reason that I need to put the dot toString in there is since it's an enumeration, enumerations are really integers. So it wants to come in there and it wants to write the number of the enumeration. I don't want that. All right, so I now have all three. I now have all three of my classes created. All right. So let's come back in LB2 and photos to here, and let's start writing this code. All right. We also, just so you know, and I didn't bring it in, this validator here, .cs, I actually want that to go in here. So I'm going to right mouse click on this. There's a couple things here. Notice this namespace is LB photos, but I want to do this. I'm going to shift click on it and drag it. I thought it would work if I try that. Shift, drag it right into the photo library and let go. And it says one or more files. This may take a long time. That's okay. It won't. So I now have validator in here. All right, but notice the namespace is still photos, where the namespace on the other ones is photo library. So I want to change that namespace. Otherwise, I don't think it's going to work. Like that. All right, and I commented this out. We're not using an is decimal. We're using an is int and is within range, and it is present in here from the validator class. So file, save all. All right, we now have in here 1, 2, 3, 4 classes. Namespace photo library, namespace photo library, namespace photo library, namespace photo library. That all should be okay now. All right, so we've got all 4 of our classes in here. Okay. Again, time to do a file, save all here, and go back to here. Now, the calculate button now does nothing. The clear button does nothing. I've got an exit. All right, I don't know if I needed a show message in there or not. I don't believe that I even used one. I don't think I used one. There's quite a bit of code in here. You've been warned. Probably a couple hundred lines of code. So I'm just going to keep going, and I'm hoping to be done with this by noon. So taking a little longer than I thought it would, which means that today we will be through this. All right, so I will do these three and I will do this as a private video when I get done with what I'm working on now. All right. Tomorrow, when we start, we will go over the end of the semester e-portfolio requirements. I'll show you MobiRise. I'll show you GitHub pages, and I'll talk about your end of semester project. We'll do that tomorrow. Then we will go into these problems right here. All right. Well, let's just see how it works. All righty. So when I clear here, when I come in and do the clear, well, what do I want to do? You may or may not have noticed this. I think I can close these. If I made a mistake, I'll have to reopen them. But when I click clear here, I want there to be nothing here. I want there to be nothing here. I want none of these to be checked, none of these to be checked, none of these to be checked, and none of these to be checked. Now I wrote this a little differently. Okay. And that is, I'm going to call in here clear frame, clear color, clear material, clear style, then clear this, and set the focus. So I'm going to call a bunch of routines I have not yet written. Okay, that's okay. So we'll put them right below here. So I'm going to call clear frame. In fact, let's put them in here and then let's write them right away. So that will be those three radio buttons. So rad unframe dot checked equal false, rad matted dot checked equal false, and framed dot checked equal false. Now, there are other ways that this can be written. There are people who could very well look at my code and say, since these were in a group box, you could have just taken the group box and disabled it, then they couldn't have done anything. Yeah, there's other ways this could have been done. I'm trying to do this in the most straightforward way possible. So clear the three types of frames, radio buttons. All right, so after clear frame, I called clear color. And I'm just going to copy this down. And there were 5 colors. All right, so they were rad black. Try that again. Rad red. Rad green. Rad blue and rad white. All right, so that should clear those two. So can I run this now and find out if that's part? Whoops. Let's go in and first reset our start project. So if I choose one of these and I choose one of these and I click clear, they should both be unchecked. And they are. Okay, good start. Then I want to clear the material and the style. All right, so I want to clear the material and the style. And now I can call clear style or clear material, I guess. And that's these. Oh, let's fix this. All right. And one more time, we will do a clear style. And the material. And this will be style. And this will be clear style. All right. Now we can call clear style from up here. We can say txt height dot text equals nothing. Txt width dot text equals nothing. Txt height dot focus. And let's fix our clear styles. All right, that's all of them. All right, let's see if these all work or if I missed something. All right, looks like it's the width that I want to show first, but everything else cleared. So it's the width I want to set the focus to. Okay, I don't have to go back and check that. That's good. All right, so we've already written about 100 lines, about 110 lines, but we've got to do a total of about probably close to a couple hundred more. There's a little bit of work that has to be done here. Again, what I'm telling you, what I'm telling you is the way that I did this. I am not going to say that the way that I did this is by far the best way of doing it. I'm telling you, this is the way that all right. So I'm going to do something you've never seen me do before, and that is up in the initialize component, I'm going to add some code. And I'm going to let the system know that with these buttons that are in here, I want to be able to set up event handlers, an event handler that will handle the framed, another event handler that'll handle the color check, another one for the material, and another one for the style. All right. So there's a few lines that I have to put in here right now. So I'm going to type in set up framed group box radio buttons. We're going to talk about what this means in just a minute, and that should be an H. Right? So I need unframed, I need matted, and I need framed. All right, you see I'm getting errors right now. All right, let's come over to here. And it says it does not contain, are you missing a using directive or whatever? Okay, well, not sure what the problem is, but we are going to fix it. Don't worry about it. We'll get it fixed. All right. And one thing well, let's see. Since I'm putting code in here, the code I usually put down here with my constants, etc. I'm going to put that up here. Let's put in our constants. But I am assuming here that the big 6 feet, 6 feet by 6 feet, or in other words, 72 inches by 72 inches. Okay. All right. So here will be my global constants. The minimum width is going to be equal to 8. 8. So the smallest one we're going to allow in here is going to be an 8 by 10. We're not going to do 3 by 5s or 2 by 3s or anything else. All right. All right. So those are our dimensions, for lack of better words. All right. The cost of an 8 by 10 is $3.99. The cost of a 10 by 12 is $5.99. The cost for other sizes is $9.99. All right. The cost of unframed is nothing. The cost of a mat is $10. The cost of a framed is $25. All right. So I just said 8x10 instead of 8 by 10. You could change it if you don't like that. All right, let me pretty this up. All right. And I did have 3 global variables that I used in here. Okay. And They are the width and the height. And the total cost. Okay, let's pretty this up. All right, now is where it gets a little weird. Okay, I am going to go in and I'm going to create basically the equivalent of a radio button group for my 3 frame buttons, for my 5 color buttons, for my 5 material buttons, and for my 5 style buttons. Okay, so all right, that's everything I'm going to be using. All right, we're still going to have to fix this. Am I missing a directive or an assembly? I don't know. Okay. All right, I'm going to keep going, and I'm probably going to run out of time before I finish because I'm only going till 12. So whatever I get done by 12 will be put out there. I will finish it then tomorrow. So let's see. Forms. There's nothing else I have in here, so I want those. Right. Yeah, I was going to say that. Probably screw it up. All right, so the next one then will be the material. Just do it. It's faster to do it like this, I think. That'll be material. And finally, the style. All right, all of that is now done. And basically, I am setting up event handlers. All right. Don't remember right now why these are not working, but we are going to fix them. I think they're not working because I haven't written the routines yet. And I'm going to do that in just a minute. Okay. All right. So this is going to look somewhat similar to what we have done in the past. I'm going to say bool. It will say use the validator.cs class to validate the width and height. We're going to write that in just a minute. And if it is valid, then the width is going to be equal to a convert to decimal, txt width.text, and the height is going to be equal to a convert to decimal. It's a period. All right. So let's write the is valid data down here. Right? Not real long, but a little bit. Now this is taken again almost directly from our textbook on approximately page 219. But we do have to come in here and with what I'm about to do here with the width and the height, we do need to set up tags. So this, oh, I already did. There's the tags for the width and there's a tag for the height. Okay, sorry, it's a little embarrassing, but I have to leave for about 2 minutes. All right, sorry about that. All right, so we're doing the is valid data now. No, I was going to get an error here because I want to say validator dot is present. All right, txt, let's just put that in multiple lines. Txt with dot text, txt with dot tag dot toString. The reason it's giving me the error, and you should be able to figure this out by now, is it doesn't have, when I put in validator right here, it doesn't know what the heck validator is. In fact, I probably can put this all on the same line. Read a little better like that. But if I come over here and click here, it'll say add reference to photo library. And boom, that error is gone. I still have the error here because I'm not returning anything yet. All right, so there's the width. We need to do the same thing for the height. Golly. All right. All right, so we've got those two done. We hit enter a couple times here. Now we don't want to validate the presence, we want to validate the numeric. All right, so we're going to say, come in here and say is int 32 for this and for this. And I better say is int 32. All right, and finally, we have to do our range checks. All right, so that'll be, and this will have to go down over 2 lines, but that's okay. We're going to get an error because this requires more parameters than I've provided. All right, so after this, we need our min width and our max width. And you'll notice the errors are now gone from there after I put in the comma. And these will be the min height and max height. All right, now all those errors are gone, but I'm still getting the error up here because I'm not returning anything yet. So if the error message is not empty, all right, we have errors. Errors. So success equal false. And let's just do a regular message box. Dot show the error message. And you have errors. Okay. Finally, we want to return success. So now, if as soon as I spell it correctly, All my errors are gone, I believe. Okay? All those errors that were in there were gone. Now, what I want to do, okay, you're going to have to watch this because I'm going to explain it and then I'm going to write my frame check changed, my color check changed, my style check changed, uh, all those check changed that I have to do. Okay? Then there's not really that much to go. There's still quite a bit, I guess. But what I want to do is I want to make sure that if unframed is checked, that all these are turned off. If matted is checked, these are all turned on, but these are all turned off. And if framed is checked, this is turned off and all of these are turned on. I hope that made at least a little bit of sense to you. All right, because that's what I have to write right now. Now, when I write those, I'm going to put it right below here and watch what happens. I'm going to put in here private, void, framed, check, changed, object, sender, event args, E. All right. And as soon as I put that in like this, now that one that we did up above, frame check change. Well, I guess it didn't like it. I thought maybe it would already give me the error would be gone. All right. So if sender is radio button, and that's the only sender that makes sense. So this is going to run. This will be the code that executes if a frame radio button option is chosen. All right. So if this is the case, that's the sender. So I want to say that's equal to, but I'm going to get an error. Right? And it looks like I can do it like that. I never did that before, but what I've always done in the past has been to take it and cast it as a radio button like that. That's the way I've always done it. All right. And this frame str is going to be equal to radio button frame dot name dot substring 3. I'm going to write this and I'm going to have to spend a bit of time tomorrow going over it with you. All right. It's probably going to make very little sense to you right now. All right, let's start with this one, and I'm hoping at least this will make a little bit of sense to you. And I need break. This says if I choose unframed right here, that I want this to be disabled. So I don't want any of them on. I don't want any of them on. I don't want any of them on. In essence, that's what I'm saying. However, if it's matted, then I want the color to be on. Let's just grab all these. All right, I want the color to be true. And let's give it a default. And I want the other ones to be false. So in English, what that is saying is if I choose matted here, I want all of these to be enabled, and I want a default one to be right here. I'm just grabbing the first one on these as a default. Seemed to me to make sense. All right, so finally, if it's framed, so if it's framed here, all right, I want the color enabled to be false. All right, I want these both to be true. I want which are rad pine and rad simple to be turned on. Like that. So that one right there is saying, oops, that one is saying that if I come in here and choose framed, these should all be turned off. These should all be available. These should all be available. And that one should be chosen by default. And that one should be chosen by default. All right. And that's everything in, oops, in this routine. No, that's not everything. That's everything in this routine. Oh, I should really put a default in there. Let's just do this, the same thing we did up here. That is, we'll make sure everything is off. So this will just be default. Like that. We can check and see if this now works. All right, I'm still getting errors there, but we're gonna, we still have the errors up here. Oh, so we've now written our frame check changed. And that should be checked underscore changed. I wonder if that's gonna fix these. No. So this should be red. Well, these errors have now gone. All right, that's good. So I'm losing some of my errors as I go here. Okay, it's a start. So next, I want to do my color. All right, and then I want to do my material, and then I want to do my style. These are not going to be real big things like this. So, you know, so let me come in here and do this. I'm going to copy a little bit. And this, get rid of that. This will be my color check changed. I should have said if. That will be if a color radio button when it changes. Okay. So if sender is radio button, radio button color equals radio button sender, and to spell color wrong. And color string is equal to the radio button color name substring 3. And I will tell you, this took me a while to figure out. All right, I Googled a lot of stuff to get this to work. So this next one will be if the material and finally we probably have the style, I would think, which is next. This is radio button material. That would otherwise give me problems. Style. Style. All right. A lot of these errors should now be gone, so all these are gone. That's good. I just have to fix these. Okay, which we will. Calculate the cost. Oh, these are all checked, changed. That's why I'm getting these errors. You'll notice the number of errors is going down markedly here. And I believe all my errors are now gone. They are. That's nice. All right. Now it's time to figure out our cost. And again, we will spend tomorrow morning the first approximately 1 hour going over all of this. I don't want it. I'm not giving you this and say, yeah, now figure it all out. All right, so that's going to calculate the size. And adding those two together will give you the total cost. All right, I'm getting errors here, of course, because I haven't written these two routines yet. So private decimal, calculate area cost. And just so that it compiles, I'm just going to return 0.00 M. Now that's fixed. And okay, so let's do the area cost first. Then we will do the frame cost. And believe it or not, after that, we're just about finished. That'll be good for timing wise, but I won't go over this until tomorrow. So I will save this. It will be out there if it works, but I'm not going to go over it until tomorrow just because I like to go 4 hours. I'm going to take a 10-minute break. Then I'm going to come back and I'm going to do a private video, which is where I'm going to do the two problems for your hands-on tests from last week. All right, so let's do this. Calculate the cost. AC is just area cost. All right, so here's that. So if it's 8 by 10, 8 times 10 is 80, so it'll be that cost that we created earlier as a constant. If it's 10 by 12, 10 times 12 is 120, so it'll be that cost. If there's anything else, it's the other size, and that's what we're returning. So let's write the other one here. So calculate frame cost. A little bit of code in here, but not a whole heck of a lot. Again, we're going to put in here kind of like we did before, but and that's what I'm going to return. Okay. So now we have to check and see if they had a frame. You notice I've got a lot of goofy looking stuff in here with substrings. I'm going to have to go over all that with you tomorrow. Notice this is where I'm instantiating. All right, and I need a break in there. Okay. So if it's a frame picture, if it's unframed, it only has a width and a height. All right. So that's all we have to worry about. There is no material cost. There is no color cost. There is no style cost. Can't be because it's unframed. Okay. So it's matted. Now, and this, like I said, this took some work to figure out how to do this. To do that, we need to do this. Okay. Now I want to make a new matted photo. So when you look at this, if it's matted, we're setting the frame cost to matted. We're pulling out the color that we used for the matte, and then we are creating a new matted photo object with the width, the height, and that color. All right. Finally, we've got framed. I'm going to put a default first, default in here that just says break. I don't want to do anything special. So this will be framed. This is one ugly whatever. And then radio button material. Text to upper, that one's done, but I've got to create another one now. For the style. You'll notice that my errors will be going down as I go through this. I could have easily missed something. Right. Something's wrong. Right. Styling. Well, it's not too bad. Oh, that's all I got wrong there. That should be an F. Fix that. It's giving me a conversion error, so it doesn't like something that I've done. Ontario. Ontario. Looks correct. Styling, parse. Style. That should say style. Oh, that was wrong anyway, but let's see. And not matted photo. That's probably what it is. Framed photo. Hey, what do you know? Return FC. Good. Let's try it. And again, I will pick this up tomorrow, but file, save all. If we choose unframed, we shouldn't be able to click on any of these or any of these or any of these. That's good. And if we say that it's 8 by 10 and we calculate, well, we're not getting anything. That isn't good. Clear works. Okay. If we choose matted, now we can go in and choose any of these, but these we cannot touch. And again, let's see. Still doesn't like something. And finally, if we choose framed, notice those two are both chosen. You can't check these. All right, it's kind of a mixed bag here. Okay. And what I mean is written a boatload of code here, but I'm missing something, and it's probably like in here. Okay, I've got the total cost. Somewhere I'm not printing out some total where I should be. All right, but it is 11:57. I'm going to call it a period. When I come back, I'm going to go back to your last test. This one here, and I'm going to do that for you. All right. So I will be coming back to do that very shortly. Tomorrow we'll pick it up. We're going to go over this entire second program because there's a hell of a lot of good stuff in it. And after we do that, we're going to go on. All right. Have a great day. I'll talk to you tomorrow morning.